Hello everyone, we are going to take a look at the conservation of momentum in terms of some car crashes, okay? So as always, the first thing I'm going to do is figure out what information is given to me. Okay, I'm going to do the truck information in blue, and I'll do the car in green. Okay, so we've got a 2,000 kilogram truck, there's my mass, driving 15 meters per second, okay? It's going to be my initial velocity. Runs into the back of a stationary 1,200 kilogram car at a red light. Okay, so stationary means velocity initial is 0. If they stick together and move off, what is their velocity? Okay, I'm just going to stick that there. Okay, that's important. We're going to need to know that in a second. Okay, and then what is their velocity? Okay. And that is my final velocity. Well, why is there only one velocity? Well, notice it says their velocity and not the velocity of the truck or car, which means they're moving off together. Like we said, they're sticking together, so their velocity is going to be the same. And so we're going to draw the situation here. Here we have an innocent little car waiting patiently at a red light. Okay, again, still not an artist. Sorry, everyone. And so we got a 1,200 kilogram car. And we've got our reckless truck, probably driven by a high school student, not paying attention, texting, whatever's going on in there. Okay, truck, right, up. Close enough. All right, 2,000 kilograms. Okay. They're moving at 15 meters per second, whereas the car is moving at 0 meters per second. Okay, there we go. There's that initial situation. Our final situation here, we have them stuck together. Okay, so we're going to have the truck. There, that's a little more truck-like. And the car is going to be connected to it more or less, at least for this purpose. Let's try that again. Okay, and it's going to be all crunched up and beaten up, whatever. Okay, so now we've got a truck, still 2,000 kilograms. Car is still 1,200 kilograms. Our velocity is what we're looking for. Okay. Now we know that our initial momentum on the left side here of these two must equal our final momentum here because of our law of conservation of momentum. As there's no other object acting on these two, their total momentums before and afterwards must be the same. And so to solve for that initial momentum, let's write out what we've got here. So our mass of the truck, 2,000 kilograms. Our initial velocity is 15 meters per second. And then our mass of the car is 1,200 kilograms. And our initial velocity is 0 meters per second. And then our mass over here, the masses are still the same. Okay, but what I'm going to say here is the mass of the truck equals 2,000 kilograms. The mass of my car is 1,200 kilograms, but as they're moving away together, velocity equals what? Okay, as they're moving together, okay, our total mass here is going to be 3,200 kilograms. Because if they're attached, moving at the same velocity, we can treat them as acting as one object. Okay, so they're going to be moving together at the same velocity, add their masses up. Wonderful. So we can now find the sum of our initial momentums. Because you find the momentum of the trucks, we got 2,000 kilograms times 15 meters per second, plus that's the momentum of the truck, plus the momentum of the car is going to be 1,200 kilograms times 0 meters per second. Okay, 1,200 times 0 is 0, so that cancels out to nothing. And our initial momentum then will equal 2,000 times 15, which will be 30,000 kilograms meters per second. Okay. Which, by the law of conservation of momentum, our entire final momentum must be that as well. Okay, so now we got to find our final momentum. We know that is going to equal to 30,000 kilograms meters per second. And our total momentum is going to come from their two masses combined 200 kilograms times their velocity, which is the same. So divide by 3,200 kilograms, 3,200 kilograms, and you will find that your final velocity is equal to 9.38 meters per second. Okay, which makes sense in our situation because if it's starting at 0 meters per second and 15 meters per second, they're both going to end up moving. Our final velocity has to be between 0 and 15 somewhere. Okay. We're going to look at the same situation almost, but instead this time the car is going to be moving forward initially. Okay, and then afterwards they're not going to stick together. So again, we'll do car is green, mass, initial velocity, mass of the truck, initial velocity of the truck, and we've got final velocity of the truck. We are looking for the final velocity of the car. Again, simple conservation of momentum question. So my truck is going to be in back here. Still 2,000 kilograms, moving at 15 meters per second again. And then we've got the car in front of it. Oof. 1,200 kilograms, moving at 10 meters per second. They get hit. The truck's going to slow down as it says. Oof, that was really bad. Sorry, guys. 2,000 kilograms still at 11.25 meters per second. And then the car is going to get hit. Whatever. Still 1,200 kilograms, moving at some velocity, unknown. Okay. Now, based on this information, if the truck slows down, it's losing momentum. Therefore, our car must gain an equal amount of momentum. Right? We are going to get our momentums each one. So you've got 2,000 kilograms times 15 meters per second. And we've got 1,200 kilograms times meters per second. Okay, so that our sum here is equal to 30,000 again, but this time we've got the 12,000 from the car is equal to 42,000 kilograms meters per second, which must also equal the sum of our final momentum here, which we've got, or we're able to get the final momentum of the truck, and we just have to solve for that momentum of the car. So we've got, again, 2,000 kilograms times 11.25 meters per second, plus the 1,200 kilograms of our car times the final velocity of the car, which we're looking for. So we've got 2,000 kilograms times our 11.25 meters per second gives us a momentum of 22,500. So we subtract that from both sides, 22,500 kilograms meters per second, 22,500 kilograms meters per second. So we will then have, let's see, how do I go down a little bit more? Oops, not that far. So we have then 19,500 kilograms meters per second equals our car's momentum. 1,200 kilograms times our final velocity, divide by 1,200. Divide by 1,200 kilograms. And we get our final velocity equal 16.25 meters per second. Okay, so you can see the car sped up, the truck slows down. The change in velocity is different, but our change in momentum is the same because, of course, our momentum is conserved. Hey, everyone, always you take it easy. Good luck and have fun.